So the agenda of this video is as follows. It starts with an introduction, followed by the production function, and then we move on to the Cobb-Douglas function, and then production in short run, and then production in long run. So starting with the introduction, let's start by understanding what is production. So production is a process by which the inputs that are given are converted into an output. The output is the one that is generally used by the consumers. The input can either be a fixed or a variable factor. A fixed factor is the one which has a supply that follows inelastic nature, whereas the variable factors has supply that is elastic in nature. Fixed factors are only found in short run, and in long run, every input that is given is a variable factor. So let's define what a production function is. A production function is a technological relationship between the physical inputs and the outputs in a particular time given the technology. This equation here represents a production function. The X output is written as a function of L labor, K capital, M materials, N land, and T technology. But for simplicity, we write X as a function of labor and capital alone. Moving on to Cobb-Douglas production function. This function is written as X is equal to A into L to the power alpha and into K to the power 1 minus alpha. The A here is a productivity factor, and alpha represents the output elasticity of labor, and 1 minus alpha represents the output elasticity of the capital. So what is output elasticity? So output elasticity is the amount of output that is produced with respect to the amount of input that is given. We also know that Cobb-Douglas function is an example of a homogeneous function. So now what is a homogeneous function? Homogeneous function is when the inputs of the function is multiplied by an n. This n can be factored out in such a way that the new function is n times the old function. So the next topic is production in short run. Production in short run follows the law of variable proportions. And this law states that as more and more units of the variable factor are applied to a given amount of the fixed factors, the output will first increase at an increasing rate, and then increase at a constant rate, and then increase at a decreasing rate. Production in short run can be represented by this equation, where X output is written as a function of L labor and N bar. The bar here represents that it is the fixed variable. N represents land. So the land is a fixed variable here, and labor is a variable factor. Moving on to the next topic, which is the stages of production. There are 3 stages of production. Stage 1, which is a stage of increasing returns to the factor. Stage 2, which is a stage of decreasing returns to the factor. And stage 3, which is a stage of negative returns to the factor. This graph shows us the trends of total, marginal, and average product in these 3 stages of production. But what are total, marginal, and average products? So total product is the total output of a good which is produced by a firm during a specific time. It can increase by applying additional amounts of the variable factor. Whereas marginal product is the change in the total product when additional amounts of variable factors are employed. And average product is the total product divided by the amount of variable factors employed. So moving on to the graph, we can see that in stage 1, the total product increases at an increasing rate until P, which is a point of inflection, then increases at a decreasing rate. Whereas marginal product increases initially but then starts to decrease. And average product continuously increases until it reaches maximum. In stage 2, the total product increases at a decreasing rate and then starts to decrease, while the marginal product is decreasing and becomes 0. while the average product is also decreasing, but it remains positive. Moving on to stage 3, which is the stage of negative returns to the factor, we see that the total product is decreasing. The average product is also decreasing, but it hasn't reached zero yet, while the marginal product goes to the negative. So which is the ideal stage for the production process to take place? The ideal stage is probably stage 2 because the efficiency of labor is maximum here. But the reason why marginal and average product is decreasing is because the labor to land ratio has reached beyond the optimal stage. And the most non-ideal stage to operate the production process would be stage 3 because both land and labor are inefficient here. The final topic of the video is production in the long run. This can be represented by the equation x is equal to a function of labor and capital where both are variable factors. Long run production functions are represented through isoquants. What are isoquants? Isoquants depict the various combination, in this case the labor and capital, using which a firm can produce the same level of output. As we can see in the graph, as we increase the labor and capital, the output also increases from 10 to 20 to 30. Similar to production in short run following the law of variable proportions, production in long run follows the law of returns to scale. So what does law of returns to scales talk about? This law talks about how the output changes in the long run when all the factors of production are variable. These are of three types. The output can either be increasing returns to scale or constant returns to scale or decreasing returns to scale. The first graph represents the increasing returns to scale, wherein the labor and capital have been increased from 1 to 2 units, but the total product have been increased from 10 to 25, which is more than proportionate. Constant returns to scale is when the inputs, labor and capital have been increased from 1 to 2, but the total product has increased to 20, which is proportionate. And decreasing returns to scale is when the labor and capital have been increased from 1 to 2, but the total has increased less than the proportionate. Hope you understood everything. Thank you.